Question 12d. In a room with temperature 12 degrees Celsius, coffee is poured into a cup. The temperature of the coffee when it is poured into the cup is 92 degrees Celsius and it is far too hot to drink. The temperature, capital T, in degrees Celsius of the coffee, T minutes after it is made, can be modelled using the differential equation d capital T dt is equal to K times capital T minus capital T1, where K is the constant of proportionality and capital T1 is a constant. Part 1. It takes 5 minutes for the coffee to cool to a temperature of 76 degrees Celsius. Using separation of variables, solve the given differential equations to show that capital T equals 12 plus 80 times e to the power of t over 5 times ln of 4 over 5. Separate the variables by multiplying both sides of the differential equation by dt. So the differential equation becomes d capital T is equal to K times capital T minus capital T1 dt. Divide both sides of this differential equation by capital T minus capital T1. So the differential equation becomes d capital T over capital T minus capital T1 equals K dt. The next step is to integrate both sides, and then performing the integration, the equation becomes ln of capital T minus capital T1 equals kt plus the constant of integration c. Raising both sides of this equation to base e, we get capital T minus capital T1 is equal to e to the power of kt plus c. Adding capital T1 to both sides of this equation to make capital T the subject, we get capital T is equal to capital T1 plus a e to the power of kt, where a is equal to e to the power of c. Now as t approaches infinity, capital T approaches capital T1, since a e to the power of kt approaches 0. And in this case, T1 represents the ambient room temperature of 12 degrees Celsius. Hence the equation becomes capital T equals 12 plus a e to the power of kt. At time t equals 0, the temperature, capital T, is equal to 92 degrees Celsius, and e to the power of kt equals 1, since t equals 0, and e to the power of 0 equals 1. Hence, capital T equals 12 plus 80 e to the power of kt. At time t equals 5, capital T equals 76, and we can use this to find the constant of proportionality k. 76 equals 12 plus 80 times e to the power of 5k. Subtracting 12 from both sides and dividing by 80, we have 4 over 5 is equal to e to the power of 5k. Taking the natural log of both sides, we have ln of 4 over 5 is equal to 5k. And then dividing both sides by 5, we get k is equal to 1 over 5 times ln of 4 over 5. Therefore, capital T is equal to 12 plus 80 times e to the power of t over 5 times ln of 4 over 5, as required. Part 2. The optimal drinking temperature for a hot beverage is 57 degrees Celsius. Find the value of T when the coffee reaches this temperature, giving your answer to the nearest minute. Solve for t the equation 57 equals 12 plus 80 times e to the power of t over 5 times ln of 4 over 5. Subtracting 12 from both sides and then dividing by 80, the equation becomes 9 over 16 equals e to the power of t over 5 ln of 4 over 5. Taking the natural log of both sides, ln of 9 over 16 is equal to t over 5 ln of 4 over 5. Dividing both sides by ln of 4 over 5 and then multiplying both sides by 5 to make t the subject, we get t is equal to ln of 9 over 16 divided by ln of 4 over 5 times 5, which equals 12.8922 and so on, which rounds to 13 minutes, correct to the nearest minute.